A very warm welcome to everyone who's gathered here, particularly our very illustrious speakers. Today, we have Dr. Deepankar Banerjee of C-STEP. As you can see, we, the Asian College of Journalism, along with C-STEP, we are organizing this colloquium on trends and challenges in science journalism. Part of the reason why we chose to have this topic today on science, the science colloquium, is because, as you know, if you look at the timetable, you will see that next Monday, I'll be speaking to all of our students about the electives, the different electives that are on offer. And we thought that if we have the colloquium now, you will have an understanding of how fascinating science journalism is for, as a profession. This science journalism is extremely popular and very prestigious practically all over the world. In India, we're proud to say that many of the science journalists who are working in the field are from our college. We have Mukund Vasudevan, we have Atira Peranjeri, we have Nandita Jairaj, we have quite a few of them who are there. But we do want to encourage our young students here to take the science elective as well. And we thought that, an introduction to science journalism, that is really the intention today. And we hope that you will be sufficiently inspired to choose this as something to learn. You don't need a background in science in order to take up something like science journalism. And we have over here, in fact, we have our other speakers, apart from Dr. Deepankar Banerjee of C-STEP, and he will be introduced. He'll be our first speaker today. We also have other speakers. We have Dr. Ramanujam. In fact, Dr. Ramanujam has been with the Institute of Mathematical Sciences, which is, they are our neighbors. As you know, it's the next street. But presently, he's a visiting professor at Azim Premji University in Bengaluru. Dr. Ramanujam and Dr. Shubhashree Desikan. In fact, Dr. Shubhashree Desikan is the person who has also been, she studied in the Institute of Mathematical Sciences. Right now, she is one of the editors at Shastra, which is a magazine from IIT Madras. Both of them, Dr. Ramanujam and Dr. Shubhashree Desikan, they offer the science elective at the Asian College of Journalism. In fact, over the years, we've had several scientists who have come here and spoken, talked to the students about science, and we've had it for the past 20, 25 years. In fact, this was something that even when we thought of a syllabus for the Asian College of Journalism, we did think very seriously of science journalism. And so, I especially want to thank Dr. Shubhashree Desikan for putting, this colloquium together, as she did last year as well. As journalism teachers, this is a great opportunity for you to even listen to the other speakers as well here. Today, we also, apart from in the pre-coffee break, we have Dr. Deepankar Banerjee speaking on an introduction to science journalism. We also have, afterwards, this will be followed by Dr. Ramanujam, who will be talking about talking science, whose science for whom. Okay, typical. This is exactly what we need to understand. And after the coffee break, we have two other speakers. We have Dr. Srinivasan Ramani, who is he's also a data scientist who works at the Hindu. So he will be talking about data stories and science. And this is in the, after coffee break. And finally, last but not least, we have Ankur Paliwal, who's here. In fact, Ankur will be telling science stories from the margins. And in fact, he's a journalist who covers science, inequity, and queer people. So I think we have some very interesting speakers, as I said, earlier. And I will now request Dr. Subhashri Deshikan to chair the session and perhaps to say just a few words by way of introducing the keynote speaker. Thank you.
So, a very good morning to everyone here. It's a great pleasure to chair the session for this excellent colloquium on science journalism with so many accomplished speakers. The idea of the colloquium was born out of a science journalism elective that Professor Ramanujam, who is one of the speakers here, and I offer. So ACJ felt a need to have an annual meeting where experts will outline the importance of science and journalism for the benefit of the students. And so we have been doing this for 3 years running now. This is the third session of the third edition of the colloquium. The first year, the theme was science journalism itself, critical science journalism. The second year was, it had a focus on medical science and all that. So the second year, we had a focus on climate change. And the third year, the focal talk will be on data journalism. So it is perhaps prophetic that we are holding this colloquium on August 9th, which is the day that Nagasaki was bombed in 1945. And it's a typical example of why science journalism is so relevant and so important today. Because if there had been a strong movement against it, perhaps that would have never happened. This is a fallout of the misuse of science, and this is exactly what science journalists are needed to prevent from happening. So with that, I would introduce the first speaker of today, Professor Deepankar Banerjee, who graduated from the Indian Institute of Technology, Madras in 1974 and obtained his doctoral degree from Indian Institute of Science in 1979. He has been the director of Defense Metallurgical Research Laboratory and then Chief Controller of Research and Development at the Defense Research and Development Organization, providing leadership of critical materials and aeronautics programs. Since 2010, he has been on the faculty of Department of Materials Engineering at the Indian Institute of Science. Professor Banerjee is a fellow of the Indian Academy of Sciences and Indian National Academy of Engineering. He has been on the Board of Governors of IIT Madras. For his contributions to engineering sciences, he's been awarded the Shanti Swarup Bhatnagar Award, which is the most prestigious under 40 award for scientists, for science and technology. In 1993, the DRDO has conferred on Professor Banerjee its Lifetime Achievement Award, and the Government of India has awarded him the Padma Shri. So I will also introduce the next speaker before we, or maybe I'll just invite Professor Banerjee to come and give his talk now and introduce them later. Thank you.
Okay, well, good morning, everybody, and thank you, Nalini and Shubhashri, for the introduction. I actually know your chairman, Sashi, since I was as young as you all. And so we were having dinner, I guess about 4 years together, 4 years back when we thought of this colloquium, and that's how all of this started. And I've been coming here for the past 3 years, so it's great fun to be here, and thank you very much again for having me here. So I'm not a journalist, as you figured from the introduction. So I'll go through this talk telling you something about what I think about the nature of science and technology and different facets of this. The heart of the talk really is the relationship between science, technology, and society. And that in turn, of course, drives the theme today, I guess. And then I'll say a few things about science and technology in India to conclude. So the word scientist, of course, was relatively recent. So 19th century. Meaning knowledge, but when did science begin? You can take your choice. You can talk about technology in terms of the wheel, 2500 BC. You can talk about the zero, which is at the basis of all computing today, and someone will talk about data sciences and artificial intelligence and so on. And you can therefore take your choice about when science actually began. But the idea that there is an interdependency between technology and society has always been there, and our political leadership in different countries have always talked about the importance of science and technology in our lives, whether it be President Obama, President Manmohan Singh, and I particularly want to emphasize these words over there, and even Prime Minister Modi more recently. So, given this background, what are we doing in science? And I want to start with pointing out that there's an intimate relationship between what was magic earlier and maybe technology today, an attempt to control our natural world, an understanding of the world, and religion. And all of them essentially address the same thing. They address our conception of ourselves and our place in the universe and how we shape our lives. So there's an intimate connection between all of this. And how do scientists actually work? And most of you, I guess, understand the scientific method as this, which is formally described as a sort of observationist, inductivist account of science, which goes something like this. And obviously, this is a method that is subject to fallacies. And today's artificial intelligence actually follows this sort of method. So the idea then is, through this method, you observe nature, propose a modest law, and so on, that tells you how things happen. But a far more rigorous definition of how scientists actually work, or should actually work, comes from Sir Karl Popper. And the idea then is that there are a number of competing ideas, and then you systematically subject them to a rigorous attempt at falsification, and then some survive and they're more fit. But none of this precludes the idea that a theory will change in the future. So the point I wanted to emphasize in all of this is that there are no absolute truths in science. And this is something we must all understand. And in a sense, it's quite similar to the idea that Amartya Sen has explored, the idea of justice. Is there an absolute justice or always a comparative justice? And I want to illustrate how the understanding of a universe has changed to follow up on this theme that there are no absolute truths in science. So you look at Sir Isaac Newton's description of the world, and here time and space are distinct entities. And then came Einstein, and suddenly time and space were not distinct entities. They were warped together, they were integrated together. And the consequence of Einstein's theory was that the universe, which was static in Newton's theory, it didn't have a beginning or end, but as a consequence of Einstein, the universe certainly had a beginning and an end. And then came quantum mechanics, and you always believe that science is deterministic. But the truth is that the model of a universe cannot be completely deterministic, and that arises out of quantum mechanics. So you can see how ideas of the physical function of a universe have changed through time. There are no absolute truths, and we don't know how it's going to change with time as we go along. And so our understanding of the physical aspects of a universe have also changed from a flat Earth to a round Earth. Aristotle over there. And then this belief that the Earth was the center of the universe with space outside for heaven and hell and so on. And of course, now we live in this sort of infinite universe, and we are really a very small speck in this universe. It's interesting to think about that. And what of life? And so the first human, about 60,000 years back, and the first single cell organism, and the Big Bang, the beginning of the universe, about 14 billion years ago. And and to point out that evolutionary theory today links all forms of life, and all forms of life are really linked to each other in ways as the universe, as life evolves in the universe. And so the similarity in genes between humans and other forms of life, the extraordinary similarity, and then of course then the idea that as we thought the Earth was the center of the universe, the idea that man is the center of the universe has changed to understanding that we are only a small part of this infinite form of life. And if you think back and let yourself think about this, about what a small role we play in the universe, in the vastness of the universe, then to my mind at least, our narrow obsession with caste, creed, gender, and so on sort of fade away, right? But this is how science works ideally. I've told you its processes, but there is a community, and we need to think about how science actually works. So this is the idea of a self-regulating community of scientists. So there's a common ethos, a sharing of information ideally, and skepticism and a belief in the pursuit of truth and so on, and a nice cartoon talking about all of that. But how does science actually work? And it was pointed out that, and you talk to scientists and they're going to tell you they're very objective. But they aren't, okay? They have ideas, but there is a dynamic between the individual scientist's ideas and the environment that there is, and that dynamic actually shapes how science evolves. And that dynamic, in a sense, is also realized in the way science is funded. For example, industrial money dominates today's scientific funding, and so all of this matters, and therefore this cartoon. And yet through all of this, science progresses. And as journalists, as future journalists, you might also be interested in the functioning of the scientific community. It's a legitimate focus of study. Its ethics, conduct, and financing and science organization is all relevant things to study. But most of us, most of the time, are really not concerned about the universe and forms of life and so on. We are far more concerned about technology, in the sense that technology impacts our lives. And most of you think of technology as tech, right? I mean, when you think of technology, you think, I don't know, you think of maybe Facebook or whatever. But to the scientists or technologists, technology has very different implications. And just to tell you something about the way we think about technology, it always tends to begin as craft, and you're in Tamil Nadu, and these beautiful chola bronzes which you can see at a museum in Egmore, by the way, were made by a process which is described in this museum, and the description and the details of the description of this process are identically applicable to the way these parts that go into jet engines are made. And so you can see the evolution of technology as a craft as it existed, translated to very advanced technology today. All of you fly in aircraft, and these aircraft last for tens and thousands of hours, right, very safely. And they're made by processes that were discovered very early on. So technology and a distinction between, if you will, technology and engineering, these two are often interchangeably used. All technology, and the idea of this is to let you know, tell you that all technology is evolutionary. I've talked about that in the previous slide, but here's an example for something that affects all of us every day and is increasingly going to affect us, and that is in genomics. And genomics, as we understood today, began with an understanding of the principles of inheritance. We went through the identification of DNA cells, the structure of DNA itself in 1953, and the human genome, and the impact of all of this, which has evolved over these decades, if you will, the huge impact of disease treatment, the ethics of gene manipulation, and its effect on healthcare, and its costs is something that you might want to think about as you want to go alone. Slightly different aspects relating to something that affects all of us today, that is artificial intelligence. And I really want to illustrate in this slide is just as we had a picture of a tree describing evolution, you can have an identical sort of picture where there are trunks and branches and leaves which describe the evolution of a technology. So there are different trunks. There is communication, there is computing, there is the transistor which underlies the hardware that is used in computers. There's the internet, the discovery of the software and so on that underlies the internet and the web. And then, of course, these ideas of artificial intelligence beginning with the notion of zero and a model for the process. And this is the name that stands out over there. Alan Turing, we'll meet him again a little bit later. And then the evolution of the artificial intelligence concepts to where we are today. So again, you can see that all technology and apparently different branches of technology are intricately linked together to something that is of importance today. And that is what I wanted to illustrate with this. So Dr. Shubhasri referred to this as being the day that Nagasaki was born. And of course, she also referred to this, the ethics, morality, and neutrality of science and technology. And many of you have seen the movie Oppenheimer, and you will recall the tensions between the people doing the development of the bomb, the politicians, the army that managed the program, and so on. It was a wonderful movie. And it captured many of these aspects. And we'll explore this a little bit more in a more recent context as we go along. And so we come to what I consider as the heart of this talk, and that is the relationship between science and society. And so on the one hand, we have science, technology, and engineering. And on the other hand, we have society as it is today. So capital, labor, production, the political, geographical, and social environment. And all of this is linked together formally through the production of goods and services. And so really technology is at the heart of historical change through this linkage, because this drives what the world as it is today, if you will. Okay, and I'm going to give you some examples of that. And I want to start with something that relationship. I'm going to start with what initiated the Industrial Revolution. So 6 spinners, before textile engineering began, 6 spinners were needed to keep 1 weaver supplied with cloth. And then the flying shuttle was invented. And this rendered the shortage of spinners critical. And so the spinners were happy because they were much in demand. Their salaries went up and so on. But you didn't need so many weavers. So the weavers accused him of depriving them of their livelihood. And then came a machine that could make more than 1 thread at a time. And suddenly the spinners were no longer in demand, right? So now the spinners and weavers were both unhappy. But remember that because of the technology that came in, the efficiency of the process increased, supply, the prices of cloth decreased, and all of us were happy except the spinners and the weavers, right? They had to go find other jobs. And of course, Mahatma Gandhi used the spinning wheel as a symbol against colonial oppression, in a sense, through the Industrial Revolution. And this is something that repeats again and again and again as technology evolves, okay? And so we come to a formal relationship between the amount we spent on research and development through technology and the gross development product. And this is GDP per capita, and this is enormous amounts of data from different countries and so on. And you can see how investment in R&D and technology drives up the GDP. And this is, of course, why you all need to be deeply concerned about the interlinkage between technology and society. And so we understand when we evaluate technology in many different aspects. primarily a concern with technical impact. But of course, as in the case of the atomic bomb, or anything else for that matter, any other technology, we worry about the resources that are available to make the technical impact. We worry about environmental impact. We worry about social impact. We worry about policy and regulatory aspects. And we worry about economic impact. And I'm going to give you an example of all of this as we go along to make it more real. I mean, these are just sort of slides saying words, but let's just see what all of this means. It's okay, right. So I'm going to do this through the example of artificial intelligence, which all of you are sort of concerned with today, I guess. And so back to Turing, okay. So this is the Turing test, and this is from a film that came out in 2014. And it says that when a human interacts with a computer, and if the human doesn't know they're interacting with the computer, that's when you pass the test. Okay? And of course, if you pass that test, you've created a conscious machine, which ought to concern you all. It's then no longer the history of man, if you will. It's the history of gods, as this movie puts it. But there are different definitions of artificial intelligence. I'm not going to go into what the science that underlies it, but just to give you some broad aspects, you can relate it to humans. The idea of AI can be related in the context of human beings, or you can relate it independent of human beings. Okay? But of course, machine vision now does object recognition better than humans. It beats humans in strategic games. It drives advances in science, and I'm going to give you an example in the next slide. And today's artificial intelligence through speech recognition and natural language processing understands, interprets, and generates human language. Okay? And so AI is already present in just about everything that we do today. And so I need to talk about the impact of that and look at the kind of funding that goes into artificial intelligence today and why all of you should be so concerned about it in different ways. But here's an example of, to my mind, really a spectacular application of artificial intelligence. The prediction of climate, which it does much better than the best physics-based models available in predicting extreme events, again, as well, with reduced error. And so how do we assess, and this is something that I wanted to talk to you about, because if you're going to become a science journalist, you're going to assess what impact a technology has on you. And there are different aspects of this, and we've talked about this already with our example of textiles, the Industrial Revolution. That is, unemployment due to our discovery of means of economizing the use of labor outruns the pace at which we can find new uses for that labor. So someone who worked in something finds it very difficult to get a job at somewhere else, and I'll talk about that a little bit more. And then ethical principles underlying a technology, which relates to policy and social impact. Is it promoting well-being? Is it sustaining the planet? What about privacy and security, the autonomy, the power to decide? Justice in a technology, is it inclusive? What about intelligibility and accountability? And of course, this is what AI promises, and this is what should concern us all. And a little bit about the economy as well in terms of labor and the share of jobs that can be eroded by automation or AI, and you can see that the job loss is highest in the least educated of our society. So you have this problem that you have to deal with, and you as budding journalists have to understand all of this to make sense of what technology can do to all of us. Okay, and I'm now going to shift to a little more physical to describe some physical impacts of artificial intelligence. And that sort of looks at the relationship between artificial energy and energy requirements. You can see how this is growing exponentially. And the impact on this is that something like ChatGPT today use this kind of megawatts of energy to train artificial intelligence models. And just to put those numbers in perspective, numbers are just numbers unless they are perspective. About 1,000 megawatts could power the average US home for 100 years, right? So you've got to compare this, okay, and understand what we are doing when some aspects of a new technology emerge, right? So, and of course, the reason why all of us think of tech as a service industry, you think of Amazon, you think of, I don't know, Facebook, you think of Zomato and Swiggy. And of course, the economy today is dominated by the service industry, whether it's in the United States, in terms of GDP, or in India. But the question you have to ask yourself, and this is an important question, is that would the world cease to exist without AI or Instagram or Twitter? But if you run out of steel, concrete, or silicon or oil, and what is the impact of all of this on the environment? And we have the sustainability drive. We want to replace or reduce the use of fossil fuel, and we need to understand, and I'm a materials engineer, so I like talking about this, is that you use about 6 tons of other materials for every ton of fossil fuel saved. And this is neat to build electric cars, turbines, solar panels, and so on. And that even doesn't account for the amount of earth and rock displaced. And I'll give you an example as we go along. So we think of technology in terms of service industry. I'm going to turn your attention away to some other aspects of this. And here, for example, is gold. All of us like gold in some form or the other. But let me tell you that you displace about 5,000 tons of earth to make a standard gold bar, okay? Just think about this, okay? And in doing so, the rocks are ground and leached with cyanide solution containing mercury, which is very toxic. So when you say gold and you buy a jewel, you buy jewelry, please think about this and have that in your mind, okay? And it's not clear at all to me whether economic activity will grind to a halt if you can't mine gold. And the gold standard has long gone. But I want to talk about something that's more relevant to AI and all of us in our lives today, and the physical aspects of this. So the journey from rocks to the smartphone, we started with the Stone Age, remember, but we are still in it in a certain sense. We mine, and I want to emphasize that when you make a smartphone today, you're actually looking at an international supply chain to make that smartphone. It is not localized in any sense at all, and the supply chain is heavily interdependent in an international context. And this is something also that we need to think about. For example, we mine high purity quartz, which is a source of silicon, and in India as well. And then we extract silicon, which is a low purity grade silicon, and that's done by India as well. But one of the points that I want to make while we talk about is that this is in the lower end of the value chain. The higher end of the value chain comes in the conversion of silicon by purification so that it's suitable for solar panels and for semiconductor grade silicon, which drives the transistors, which drive your smartphones and just about everything in the world today. And the Chinese can't do this. This is dominated by the US, okay? So you can see this international linkage as we go along and continue. And so that silicon then is made into wafers like this in different countries. And finally, you come to chip making, which is the end of the value chain, and packaging the chips. And certainly Taiwan and Malaysia dominate these aspects. So your smartphone and everything else in the world comes through an international supply chain, and a break in the supply chain, the physical aspects of the supply chain can break the world as we know it today. And science journalism again. And so I want to talk about 2 examples of potential breaks in the supply chain. The quartz for making silicon for semiconductors is mined at just, the quality of quartz that is required for this is mined at just one place in the world. If this place today ceased to exist, the world as we know it would cease to exist. Okay? The way you make chips, the technology of making chips, the high-end chips that are used in the most advanced applications, each machine that is used in this requires 1 megawatt of electricity. It costs about $150 million. And the Taiwan Semiconductor Manufacturing Company, which makes most of the advanced chips that are used in the world today, has about, something like 80 of these machines? Okay. So you need, again, to look at the energy consumed in making chips. And I'll give you some more numbers, but this company today will use more energy than the entire 21 million person population of Sri Lanka. So when you use a smartphone, just think about what you're doing, okay, in terms of the energy that you're using up. And you don't think about this. You think about goods and services, but you don't think about this very much, okay? And so just a comparison, you know, and we talk so much about climate change these days, and that's related to greenhouse gas emissions. So cement produces 6 to 7% of greenhouse gas emission, about 1/10 of the water for industrial use. But if you look at the energy requirement for chip making, it's extremely energy intensive. Okay, the numbers as compared to steel and cement are extremely high. So in terms of tons of chips produced in relation to the tons of metal and cement, chips are obviously just small, tiny things and much lower tonnage. But in terms of energy intensity, it's significantly higher. So in the end, they all become very similar. So when you make a chip, you are emitting greenhouse gas emissions that then affect climate change, okay? It's wonderful to have a smartphone. But if you think of sustainability, you have to understand these balances. And water, okay? I talked about energy and greenhouse age emissions. And so the semiconductor industry consumes about 260 billion gallons a year, okay? And again, to put it in perspective of how much you use in a small city and so on. And so when you want to invest semiconductor manufacturing in India, you have to think about energy and you have to think about water, but you have to think about the net benefits to society and labor and so on. So these are the balances that you as science journalists would constantly assess. And as Dr. Nalini said, you don't really have to know science for all of this, or the details of science. Okay. And so I'm going to leave that and talk a little bit about, we talked about R&D funding and its relation to the gross development product, but here's a little bit about R&D in India. So this is where we lie. And this is in terms of the amount of money we spent on R&D in relation to some of the other countries. And we lie somewhere here. So the United States spends about $600 billion US, and this is 2000, fairly recent figures. India spends about 150, okay? And in terms of purchasing power parity and as a percentage of the GDP, we are actually much lower in our investments and in relation to a gross development product. And there is another distinct differences that when you think about all this as journalists that you need to be concerned about, and that is the industrial spending on our R&D is far lower than the industrial spending on R&D from other countries. There are different forms of R&D spending, the government, the industry, and so on. And I want to particularly focus on the lack of industry spending on R&D in our country. And that affects the innovation in our industry, okay? And so that's something that you want to think about as well. We have a structure of science and technology which broadly looks like this. And this is just background information for you all to understand the way science and technology in our country is arranged. And I'll show you some pictures. And you can go back and ask yourselves, do you recognize these faces? And that's something about general knowledge that perhaps one should think about. So I don't know if you know who that is. Of course. Homi Bhabha, okay. And Sarabhai, the Space Center, but one person. And this is because you're here, and the Swaminathan Foundation is here. And we think about the impact of science and technology on society. And you're probably too young to remember the food scarcity we had and the famines, near famines we had in the 60s. And of course, Dr. Swaminathan, with his discovery of high-yielding seeds, and not just the discovery, but the mechanics and the politics and the policy of translating these high-yielding seeds into the farmland, he really, today, you don't think about food security. And we really are, in a sense, deeply dependent on him for this. So we have a very large commitment to higher education. We have different governments over the years have invested heavily in higher education. You might ask yourself the question, is there adequate quality primary education to back all of this up? Okay, and therefore that leads to an analysis of supply, demand, and availability, and something that should concern us all. Today, with our commitment to higher education, we produce some of the highest numbers of science, technology, and engineering graduates. But apparently, and this is from the Economic Times, about 20 to 30% of these 1.5 million engineers passing out run the risk of not getting a job at all. Okay, so we again need to understand all of this in terms of employment and so on. And so, what we do at the Center for Science, Technology, and Policy is to understand this balancing act, and of all technology, and I've given you different aspects of this balancing act. So the effect of investments in technology on GDP. Today we are increasingly concerned about climate change and different aspects of sustainability. I've talked to you about the way we mine our earth for materials, the effect of greenhouse gas on emissions. We've talked about the security of supply as well. I talked to you about how quartz is, the high-grade quartz available in one place in the world. We talked about how machines are made in just one country in the world. And that relates to national security, right? And we talked something about sociological aspects. We talked about employment, and there are other aspects that we need to concern about, migration and cost and benefits of behavior. And we do all this at the Center for Science, Technology, and Energy Policy. And any of you should wish to come and intern there and embed yourselves in our system for some time. We'd be very happy to have you to understand these relationships a little bit better. And you can get involved enough to write op-eds if you wish, if you join us, okay? And so a very small example of the kind of impact I've talked about the effect of chip making on greenhouse gas emission, okay? But of course, greenhouse gas emission is intimately related to global warming. And global warming then is related to rise in sea levels. And this is an example of a recent study that predicts a rise in sea levels in Chennai, okay, with different estimates of global warming. And these are pretty alarming. And this data then shows you the levels of inundation that can exist. And so you can superimpose this inundation on land use, whether it be industrial land use or residential land use or whatever. And this is the kind of study we do at CSET to understand effects on science and technology on our life in general. And so I'm going to conclude here now. and sort of summarize what I've said. I've tried to tell you in different ways that science and technology is really woven into the fabric of our society and has very large-scale impacts, and I hope I've been I've been able to convince you about that. And so we need to make choices about which technologies will be used and how, and the scale and direction, the way we use scarce resources, and the way we make those choices will determine our well-being in just about all aspects of our lives. And of course, these choices are too important to be left to scientists and technologies and engineers alone. We've talked about social impact. We've talked about economic impact. We've talked about sustainability and so on. So the public understanding of science and technology is as important as doing science and technology, given all this. And therefore, as Dr. Nalini said, I'd like all of you to take up science journalism. Okay? And of course, I was trying to persuade Sashi yesterday that his 15 cap limit on elective, he should relax that if all of you take up science journalism, right? But wishing you all the best in your life and your careers ahead. Thank you very much.
Hello, sir. Thank you for the talk. I wanted to ask, you mentioned the energy requirements of AI systems such as ChatGPT and all. I wanted to ask about the possibility of policy regulation regarding the energy and water usage of such AI technologies such as ChatGPT, Gemini, and other transaction forms as well, such as cryptocurrency and NFTs, because at present there's also not a lot of transparency from big companies such as Google about how much energy they're using. And a lot of times their data servers are built in water deficient areas such as deserts. So I wanted to ask about that, and also what the way forward is for grappling with such impacts of new technology.
Right. I mean, so which is why I guess I had that slide about how technology affects very different aspects. And we have to understand that on the one hand, we're generating productivity through artificial intelligence. On the other hand, the same increase in productivity is affecting our environment in different ways. To make formal, rigorous assessments of each of these effects on different sectors, whether it be healthcare or whether it be services or whether it be, I don't know, transportation, whatever you think about, that formal assessment is not a trivial task. And we're going to have a talk about data later on. And really, in answer to your question, these are very diverse requirements, but at the heart of it all and making these assessments lies the idea of data. And the question is data available? What is the quality of data? Are there limits to the data that are going to be available when you carry out artificial intelligence processes? I think we are already reaching the limits of data available through the internet to train artificial intelligence systems. So that's another aspect that I didn't talk about, the availability of data and how we need to generate high quality data to make the assessments that you're asking about. So we need more, the answer that I want to give you is that we need more organizations that evaluate formally the effects of science and technology on different aspects of our lives in a very detailed manner so that those recommendations can go as policy to the government and the people who make decisions. I can't answer in more detail than that because that's the way it has to be done. And it's being done in some senses, but not in the way that we should be doing it in our country. Okay. I don't know if there's more detail that you wanted, but that's, yeah.
I wanted to ask about, like, currently the pace of technological development is very, like, it's very fast. So often we are not able to pace up with the questions of ethics, morality, and other important environmental aspects of it. So how can we, like, cover these stories without, like, sounding very skeptical or alarmist, at the same time not giving a very positive outlook on these things?
I want to sort of respond to that. I mean, there is this notion that the pace of technology is very fast, okay? And yes, it's true, things seem to change, very quickly at times. But if you really look at the development of technology, and I try to show this today, it's actually evolutionary over decades, okay? And I believe you have sufficient time to make assessments, provided you decide to put resources into making these assessments, which was my answer to the first question. So don't be too skeptical, okay? I also want to, and you touched upon this in an indirect way, I want you all to look at carefully at the end, well, what's the right word to use? The entertainment is not, but the sensational aspects of what we talk about vis-a-vis real analysis. And I want to request all of you to focus on real, rigorous analysis rather than sensational aspects. It's very easy to say, look, AI will destroy the world, but really it's going to do many things to our world. And to provide a balanced view of all of this is what I think is required of the media.
So, good morning. I had a question. So this is with respect to how certain choices in our life are sort of presented as sustainable. Say, for example, if I want to buy a car, EV is presented as a far less guilty choice than a fuel car is. So, but if we look at the scientific aspect of it, probably the supply chain of an EV car would probably cause the same damage or even more than that of a fuel car. So do you think that this whole idea of choices being presented to the larger public as sustainable is more or less a myth?
It's not a myth. Again, in relation to the first two questions, everyone today does a life cycle analysis, which is, by life cycle, I mean from the start of generating a resource to the final product, and all the issues in terms of labor, in terms of emissions, in terms of energy use. Today, you do life cycle analysis and you come to a certain conclusion. And because there are no absolute truths in those analyses, and it depends on something we touched upon, that is the quality and quantity of data, different people doing the analysis can give you different results. But I think broadly, the way science progresses, you will get the same broad understanding. And you will get an understanding that EVs, in the long run, through the life cycle, are more beneficial than using petrol. Okay? So that's about all that I can say to that.
I think we have one, yeah. You can, Tarun can just.
Yeah, Tarun has a question. He's been waiting.
This is the last question.
Okay.
Hello, sir. Thank you for the talk. And in your talk, you mentioned that there is a great relationship between the development of technology and how technology is dependent on how it increases productivity. The development of science and technology in our society is greatly dependent on whether or not it increases productivity or not, whether or not it increases profit or not, and those are the only studies which are usually funded or given more leeway in the institutions. So,
Right.
Isn't that counterproductive to the larger innovation of science in our society, or how it moves forward?
Yes, of course it is. And I talked about this in some of my earlier slides, that what drives funding comes from different, let me call it vested, some are more independent than others, resources. And so you as science journalists, or all of you future science journalists, when you report things, you have to also understand where money is coming and how it might influence the results of studies and so on. And that should be part of what you do in order to interpret the effects of science and technology on society. That should be part of your studies. But as in everything else, I want to tell you that there is a balance to everything that happens. There are pulls and pushes and tugs and stretches, funding from some sources, biased sources, funding from independent sources. And in the end, we arrive at a media and a democratic society that sort of moves forward with our lives. Okay, so, yeah.
It was
Thank you
a
very
lovely
much,
lecture.
Dr. Banerjee.
Thank you.
Yeah.
Thank you so much.
I would like to say a few words about, I really enjoyed your lecture, and it was really thank you very much. I'd like to invite the next speaker, but before that, I will just introduce him. Professor Ramanujam. Dr. Ramanujam was a professor at the Institute of Mathematical Sciences, Chennai, until recently. He was there for more than 30 years as a computer scientist, and now he's a visiting professor at Azim Premji University. His research is in theoretical computer science and mathematical logic. He has also been associated with the Tamil Nadu Science Forum, a voluntary group involved in science communication and education. He's the editor of Tulir, a monthly children's science magazine that's published in Tamil by the Tamil Nadu Science Forum. This was the very short bio that he had given me. I must add that he's also the recipient of the Indira Gandhi Medal for Science Popularization given by Indian National Science Academy. I invite Professor Ramanujam to come and give his talk now.
Thanks very much, Nalini and Shubha, for the invitation, and thanks, Shubha, for the introduction. Okay, I think I'll move a bit of a light there. And thank you for inviting me and giving me this opportunity to talk here. After that amazing capsule history of science, society and science, I thought it's an excellent introduction to the elective as well, because if you actually do the science journalism elective, you would see some bit of history of science and philosophy of science and extensive discussions on science and society. I was glad he didn't have time to answer all those questions, because those are the questions that we should really be discussing in the science journalism elective. So thanks for the advertisement, Professor Banerjee. And so I'm going to talk a little bit about something different. This is not really, I'm not a science journalist. You should blame Nalini and Shubha for bringing me here. I've never earned my living, writing articles, publishing, and I respect people who can do that. I've been earning my salary proving theorems all my life, down the road in math science, and even now what I do. But I've been doing science communication out there, and I want to talk about that. When you talk about science, when you write about science, I'm not going to talk about writing at all. I'm just going to say general science communication. But to whom? Who are we doing this for? And if we talk about the kind of issues that we just heard about, okay, who's going to understand? Who am I doing this for? I've always been worried about this. As a scientist, if I do want to communicate science, the excitement of doing science, there is so much, and also the problems of science, but whom do I communicate to and how? So let me begin with my first lesson in science communication. And this was part of Tamil Nadu Science Forum, which was mentioned, a voluntary group. And way back when I landed up in math science, so we said, for science popularization, one of the best things is astronomy. And we said, okay, take a 6-inch telescope, two of us, another good friend of mine who's an excellent science writer, T.V. Venkateshwaran. So we knew a teacher, in Chengalpattu district, and we went to his village, a small hamlet. And one of the things that villages are rich in and cities are very poor in, what is that? The night sky, really, yeah. So you want to look at the sky, go to a village. There's no light pollution. So we said, okay, we'd do a sky show, and the idea was that we would show Jupiter. It was something exciting to see. You could see Jupiter at the time in the evenings, and we would show Jupiter. So this was the deal. So we showed up, and in the evening went around looking at fields and orchards and all these. Then at about 8 o'clock we said we will set up and we'll have the sky show. The show turned out to be an utter failure. Why? Why do you think it didn't work?
Pollution from the nearby factories.
Pollution? No. Hey, this is no factories nearby, crystal clear sky. Okay. What else? Sorry? Nobody came?
Or nobody had a conception of...
Nobody had a conception of? What do you think was the problem? Cloudy? No, actually I thought people would say that no, this was a clear sky. No clouds, no rain, nothing. Yeah? Sorry?
Nobody knew what it was about.
Very few. Huh? Yeah. So this is what actually we were worried about. The problem was too many came. Not that too many came, too many children came. There were 50 children all around us, climbing all over our heads, wanting to look at. By the time we set up the tripod, if you ever set up a tripod, telescope and look for Jupiter through the telescope, how do you think Jupiter will look? Do you think it will look like the sun? A huge ball? No, it's going to look like a dot. Right? By the time you have set up all that and somebody says, oh, is it like this, and it is moved. And by the time 5 children are on top of you screaming out, me, etc., and we were completely unprepared for that. Right? So it is a disaster. And meanwhile, the teacher started saying, hey, start like this, and he said, no, don't do that. And so it was chaos. Okay? One small change in the program and it became a big success. What do you think that was? Who cares about Jupiter? We realized that there is a half moon hanging there. So, and what is the difference between looking at Jupiter through the telescope and the moon? What tripod, what adjustment? Nothing. Anybody can turn it around and look at the moon. Right? So we said, let's look at the moon. And all children wanted to see the moon. Who wants to see Jupiter? Right? You are an amateur astronomer. For you, showing Jupiter and Saturn is a big deal. For Janta out there, and another remarkable thing happened. The children ran to the village. For what? To get their mothers. Amma, nella kaatranga. That was the thing. Right? And the mothers came. Right? So, now suddenly the program was completely different. Because people wanted to see the moon. The moon is culturally rooted. Every mother holds the baby, I hope fathers too, hold the baby on hand and sing some song or talk about moon, show the moon and feed the baby, right? This is the most traditional thing you can think of. So everyone wanted to see the moon. And a half moon is wonderful, right? Of course, new moon is terrible, you can't see. And the full moon, it's too bright. Half moon is wonderful because you can see the craters. You can say, that is where Apollo 11 landed, Armstrong landed, right? Now, why do I call this a lesson in science? For me, this is a revelation. Science is not what you think you want to talk about, but there is some understanding out there, and something that's culturally rooted, what people are thinking about. When you talk that language, that night, we were actually sitting and talking till midnight. There were neoliterate women sitting there who had been to school for maybe class 3, class 5, asking us questions. We were talking about stars, we were talking about nebula, we were talking about supernovae. It's possible, right? So, of course, what you showed through the telescope was only the moon, but there is so much to talk about, right? Once the conversation begins, you can talk a lot. But that beginning of the conversation is not trivial. It's not something that happens if you go in with your idea of, this is science, this is what I want to tell you about. And this is not easy. Anyone who has ever taught anything knows the hardest thing is to listen to your students. Much easier to talk, right, than to listen. Similarly, much easier to, when you communicate science, to say this is what it is and not listen. Now, in the International Year of Astronomy, Transit of Venus, Eyes on, eclipses, there have been like 100 such programs. We've done lots and lots of many, and I would still say astronomy is perhaps the you know, and even today, at any group, Mangalyaan, Chandrayaan, talk about any of that, there is always more receptivity than anything else that you can talk about. There is something fundamental about astronomy, how it captures the passion and interest of common people across society. Okay, so here is another episode that I wanted to mention. I just want to mention a few examples, my experiences, and in this context. Now about, again, I am only talking about talking science in rural India with children, with people who have probably been to, not had great schooling, and we are not talking about the readers of the Hindu here, right? So, well, I hope they are readers of the Hindu too, so I have no problem with that. I would love them to be, but what I mean is that this is not the given thing. Okay, so again, been doing a lot of this sort of thing. So once we're in some village, go around in the evening, night is the sky show, so you go around with children. My guidance chief, 12-year-old Kuroma, as we walk around, she's showing me trees, birds, plants. She knows about medicinal herbs, insects. Children know far more than most adults about insects, with the exception of entomologists. But she has plenty to say. And I don't know. I mean, I'm a town-bred guy, right? What do I know about trees and birds and insects and things? I am also a mathematical scientist, right? I mean, so, and of course, you know, I am the scientist, right? They all laugh and don't quite believe, and I say, I don't know. The truth is, I don't. And brown sugar, nati sakkare in Tamil, and the properties of molasses. I mean, there are places where they are making vellam, you know, good out there, and she knows about it. She knows the processes, production processes of all these things. And she can actually identify many constellations in the night sky. Now, this is something you go anywhere in India, anywhere. People know many constellations and point out and can tell stories around them also. So, next morning, I'm leaving, I stay there, and next morning, I call the children, come to say bye, and I tell Kuroma, you'll make a great scientist one day. So, of course, everyone laughs. Sir, I never get more than 30 marks in science, right? Now, okay. So, what are the chances that Kuroma would grow up and become a scientist? Enter the hallowed portals of Indian Institute of Science, ICERs, IITs, IGCAR. What percentage would you put it? More. But what percentage? Come on, Venkatesan, give me a number. I'm looking for a number. No, I'm asking for a probability. What is the chance that you think that Kuroma is going to become a scientist? Join C-STEP, right? Yeah. What numbers would you give? 30%, 50%, 80%? 5? 100%? What are the chances? 100% you are saying? Okay. 5%? Under? Oh, sorry. I heard 100%. Under 5%. See, the thing is, I've done this poll. I mean, I gave this talk at the Indian Institute of Science a few years ago, and I was asking. Now, it doesn't matter whether I'm asking in IISc or in anywhere. Nobody is putting the chances very high. Something is wrong with our society if it's crystal clear that across audiences, we are going to put the chances of Kuroma somewhere below 5%. That means there is a social acceptance to this, that this is all we expect. Somewhere our expectations are like that. So, and that is based on certain understanding of reality, right? Now, this understanding of reality is very important, because if I do not see myself as a scientist, right? If I do not see myself participating in the production processes of science, in the production of knowledge, how do I communicate knowledge with that person, right? Now, where do you think this starts? In the classroom. It's in the science classroom that we see ourselves doing science. How else do we learn science? How else do we do science? And what is doing science anyway? Now, why should that be important to journalists? We'll get to that later. Let's not worry about it for the moment. At least indulge me in just thinking about that. Here is a question. Go to any class 9. classroom. What's the boiling point of water? 100 degree? That's all? Okay, fine. 100 degrees Celsius. How do you know? How do you know? Yeah, I'm asking, how do you know? Yeah? Anybody? How do you know? Sorry? It's in the textbook, please. Has anybody done this experiment? Please, I would like a show of hands. Anybody done this experiment too? I see some fortunate people. How did you do this experiment? What kind of thermometer did you have? Yeah, but what thermometer? See, the normal thermometer that you use for your fever, what is its range? Okay, 100 degrees Celsius, no hope of this. You need a lab thermometer. Now, in my school, I never saw a lab thermometer. It's a very trivial thing actually to see. You go to a medical shop, you can ask and you can at least look at it. Okay, so lab thermometers are all around us. It's not that difficult to find. But the point is, we don't do the experiment, right? This is not something that, we are not talking some super duper high funda 21st century technology here, right? It's a common thing that we can think of. But here is the problem. If I actually do the experiment, I have now done this experiment 50 times, 100 times in schools with teachers, children, whatever. And in groups, we actually make different groups, we boil water, put the lab thermometer, and what do you get when you do this? Since you have not done the experiment, you don't know. You never get 100. You get 99.8, you get 100.2, you get all sorts of things. And interestingly, you do it in 5 groups, all 5 are getting different results. So, what's going on? Well, so is the book lying? You all said, nobody had a doubt. Did anyone say, when I asked what is boiling point of water, did anyone say 100.2 degrees? 98.6? No. You all said in unison 100 degrees. So, but then the soul of science is supposed to be experimentation. How do you accept something to be true in science? By experimental verification. This is what is the fundament. This is what distinguishes science from any other knowledge system, right? In mathematics, the gold standard is proof. You accept something to be true if you can prove it. In science, you accept something to be true. In religion, maybe you accept something to be true because it's God's word. But in science, it's supposed to be experimental verification. Well, firstly, we don't do the experiment. When you do the damn experiment, you get all kinds of results. How do you understand? Is the book lying? More important to me is, why is nobody asking this question in the classroom? Why are students not asking this question? Why are the teachers not raising this question in the classroom? Which water are we talking about? Well water, tap water, metro water? Yeah? Do they all have different boiling points? Well, yes. Why do they have different boiling points? Oh, okay. So, okay, some minerals dissolved in water is coming out now, right? What about river water? Would river water have a different boiling point than from our metro water? Do you know where metro water comes from? Whatever metro water that you have in Chennai in the hostel here, where is it coming from? Okay, so I don't want to go on with this nonsense. The point is that every statement in science that you talk about, there is a negotiation involved. This negotiation, science lives in this discussion, right? When you say minerals, what do you mean minerals? Where do these minerals come from? How do minerals affect boiling point? If I change the minerals, can I check that the boiling point actually changes if your assumption is true, right? Can I test this? What is the boiling point of sambar? Do you think sambar doesn't have boiling point? Of course it does. What's the boiling point of fish curry, right? Yeah, and if I'm putting imli in it, as I change the imli concentration, does the boiling point change? And if you say it does, I will ask how. And if you tell me how, I will say, okay, can you give me a graph? Is it linear? Right? Can you give me an algebraic expression for it? Can you compute? All this is where science happens. Now, if science, doing science is about this, and these processes are completely alien to us, right? We cannot see ourselves as people who do science. We cannot see ourselves as scientists. The model that until class 12 you keep, mugging, desperately memorizing, and suddenly somehow you will become a scientist, right? By doing well in certain exams, is not how I would think that, science would go in the general public. If we want public engagement with science, I think somewhere our science classrooms must change. Now you can say, why are you telling me this? I want to be a journalist. But we'll come to that. And if we don't, remind me. One more scene. Okay, this is in some Paramakudi interaction with children. Now this is something that you always do, and I don't know, probably children hate it. Adults love to ask children, what do you want to become when you grow up? Right? It's a standard deal, right? And you ask children around, and normally for 20, this is also changing quite a bit. About 20, 30 years ago, typically children would say, I want to become a policeman, I want to become teacher, much less now. So many such things, because this is what they see from their lived experience. Manikandan suddenly says he wants to become a scientist. And I was very thrilled. So here is some kid who actually says, I want to become a scientist. So I ask him, what would you like to do? Becoming a scientist. He says, I want to become a scientist and make an idli machine. He didn't say design, he did say idli machine. Now, this is very interesting. This is a very interesting thought, and how does this come about? Turns out that, in Tamil Nadu or many parts of India, southern India definitely, you get off anywhere, get off at the bus stop, at a bus stand, town bus stand, there will be a few women selling idlis, right? This is the standard sight that you see. Manikandan's mother is one of them. So every morning she makes idlis, goes and sells, and so he knows what it means. It's a single parent family, she's raising 2 children, and he sees the struggle that she's doing and he helps her at home. So he realizes that an idli machine would probably make the business profitable, right? That's where this is a child, okay? These are not well-formed ideas, this is not business model or anything. It's a lived experience. He's asking this question. Now let me again ask this question. Let me wave a magic wand. Manikandan does extremely well in school, cracks JEE, enters IIT Madras down the road, and gets a BTech in mechanical engineering. What are the chances that he would be able to design that idli machine, or what are the chances that he will do that? He will design an idli machine. Something happens. I did my undergraduate degree in electrical and electronics engineering in BITS Pilani. One thing for sure is that the way I learned engineering and the way you learn technology is not how you do this. For a variety of reasons. Let's not go into that. But my chances are, at that point, after my BTech mechanical engineering degree from IIT Madras, I probably wouldn't be sitting and designing idli machines. So, I'm pointing out that the structure of our society, the structure of the kind of alienation from science that happens in classrooms, the kind of alienation from design and technological processes that are inherent in technology education that we have got, all of these go into the makings of producers of knowledge, producers of technology, consumers of knowledge and consumers of science and consumers of technology. And I haven't even breathed the word market in all these things. And I haven't mentioned the word government in all these things, right? So if we are talking about relationship of science and society, I think, and if we want to talk science meaningfully and actually empower people to answer the kind of questions that my friend there raised about electric vehicles, right? If we want to make choices, if you want to make if we want society to be making choices, right? Informed choices where, as Professor Banerjee wants, the public actually pressurizes policy makers to adopt certain stands, right? For those movements to build, I think, we need to start out there with the Manikandans and with the, all these people out there, right? Otherwise, it's going to be in the hands of experts and committees and, somewhere. So if you want a political understanding of science and society, I think we have to look at what the public actually understands and how, even if we talk about a society in which you reach universal levels of school education, which is all that our society is looking for. So, okay, this is another fundamental thing, this is something to think about. How does our education system relate to technology in general? What's the kind of attitude to technology that you build in your 10 years of compulsory schooling, right? So, are we building only consumers of technology, or are we building creators and innovators of technology? Yeah. So, these are things. So, I mean, classrooms are very important in this, including our classrooms. And when I say classrooms, please don't think that I'm only talking about primary school classrooms. I'm talking about PhD students or wherever, right? Children rarely talk science. I write children, I'm sorry, I'm too old. I should say students, right? Students rarely talk science. Students rarely talk science in the classroom. And these two are different things, and both are extremely important. And students do not get many opportunities to do science outside the classroom, especially at home, out there. And rural students, especially girls, can rarely see themselves as scientists. Let's not forget Kuroma, okay? There are Kuromas and Kuromas all over, not just in India. Think of Africa, think of, half of humanity, right? They do not see themselves as scientists at all. Here is another episode that I should mention. So this was in 2020. We all know what happened in 2020, the pandemic, and Tamil Nadu government was distributing Kabasura Kudineer to all COVID positive patients. I was COVID positive and I got my sachets of Kabasura Kudineer as well. And I, drank some. I don't know whether I used it all. So I was having some discussions with students in a city college, and I asked this question. This was a Zoom poll. And there were I think some 400 students online at that time. I don't know how many were listening, of course, online. But a poll is interesting because people actually participate. So I asked, and I found that, so I asked this question, is Kabasura Kudineer a cure for COVID-19? And almost everyone had a vehement yes or a vehement no. This was very interesting because, it was almost, I would say, I think, practically an even split. Practically an even split between people saying yes and no. And I invited people to say why they thought it was yes. The discussion was largely on an emotional plane. Those who said yes gave a lot of gyan about how traditional medicines are important, traditional knowledge systems are important, nothing about Kabasura Kudineer in itself. Okay, so generally traditional knowledge is important, traditional medicine is important, therefore Kabasura Kudineer is important. So this seemed to be the kind of logic. And those who were against it said, how do you know? What is this? This is all nonsense, etc., etc. This is a virus. Okay. Whatever happened to evidence-based reasoning? What bothered me was that the students were not asking where is the data, right? I mean, I would have loved that question, right? So the point is that somewhere you should be looking for data. I mean, without data, and if I present data, then you can question the data. Can you say, does it follow from the? But if you are not even asking such questions, and look at public decision making that we are getting used to. We have elections, we just had one grand election. Where do we talk about data-based evidence, data-based decision making as a political demand, right? Evidence-based decision making. Are we looking at it as a demand? Do we tell every contestant for member of parliament, what data would you look for taking a decision on this. No, we have given up on that. This is precisely the thing, right? So basically evidence-based reasoning, data-based decision making are not part of our discourse there, right? And this is something that comes across in these kind of things. Now, our policies have talked about these things for a long time. I don't want to read the quotes and go on with this. The 2005 National Curriculum Framework, on which curriculum was developed 20 years ago, talks about processes in science, experimentation, making observations, all these things. NEP 2020 speaks of critical thinking as a goal of science education, doesn't go much further than that. Main point is that there is a huge gap between the goals of science education and what actually takes place in the classroom, again at school level or university level or research level or wherever, right? So basically how, if you look at the earlier policies, from whatever we learn of science, are we generating manpower for economic growth in an S&T based society? How does it create scientific temper in our students? Does Kuruvama have any hope of joining the experts, middle order workers and scientifically literate citizens? This is a quote from NEP that this vision calls necessary. Or can Kuruvama expect to understand the process of science, internalize them? Yeah, so maybe again, let me go past this. There is another very important dimension, right? I would say this is not just about science education, though that's what my slide says, but science communication, right? The advent of mass education and Western models, right, was accompanied by an enlightenment mood, right? If you read 1930s, before independence, people looking at prospects of education, right? You read Jawaharlal Nehru, you read Gandhi Kumarappa, you read Zakir Hussain, you read any of these, there is this enlightenment mood. There was this expectation that somehow science and education is going to be a means of liberation from casteist and religious domination of social practices. This is something this is an expectation that you begin with. Science has always been seen as an important weapon in the battle against forces of obscurantism and superstition. And science education, remember that, I don't know, do you know when science education became compulsory in schools? When did science become a compulsory subject in school in India? Any guess which year? I know most, with the exception of some 2-3 gray hairs here, most people are too young to know. So, when did, any guess? I'm just asking for a guess. When do you think science became a compulsory subject? Early? 1990s? No. Science has been a compulsory subject even when I went to school. I mean, I'm much older and all that. So, when do you think? 1950s? Yeah, okay. This is usually what I hear because for some reason this is associated with independence from the British Raj. Everyone assumes that, and it's true to a very remarkable extent because one of the first policy documents that came out of this country was the science policy document, and we have Jawaharlal Nehru to thank for that. One of the very early ones, 1948, right? But science was not a compulsory subject in school until the 1968 policy on education, and Malcolm Adiseshaya's curriculum for the 10-year school was a turning point. It was only in 1971 in Tamil Nadu it became a compulsory subject. Much of India by 1972 it was. So it's not as early as 1940s and not as late as 1990s. But my point is that all along science education has been an essential component of modernization and social transformation. So what I want to point out is science education and science communication in India reflects inequity. And if this is something that we do not understand, you cannot take sides. And I think you should take sides. This is all I want to say in this. In terms of academic performance, which is the passport to economic upliftment, Kuruvama has no hope of becoming a scientist. In terms of processes that encourage critical thought, that lead Kuruvama towards freedom from fear and prejudice. School science seems to be of no help whatsoever. Remember, Rabindranath Tagore, in that famous poem, talks about, well, let's not go down. But my point is that these are the expectations that you have got. And to me, science is about freedom from fear and prejudice, right? And if science doesn't teach you that, right? And science communication doesn't give you that, right? There's something grand about the universe, right? Back to the telescope. One of the things that our science journalism, science communication class in ACJ, we did was this idea that how many people have looked at even the moon through a telescope? Yeah, let me ask this question. How many have looked at, so, Nalini, I've said this before, you need a telescope on the rooftop. Mad Science, just down the road, we had night sky sessions, and I remember whole of ACJ turned up. All the students came, and there is something fascinating about looking. I mean, you have to look at Saturn through the telescope. I assure you it changes your life. I give you a written guarantee, right? So it will change your life. Look at Saturn through the telescope, look at Saturn's rings. That's not easy. But let's look at the moon. Huh? Let's not forget that you have to look through the telescope, you have to look through the microscope, right? And these are things that show you things larger than life. Smaller, anything that's completely out of scale from human dimensions, right? Galaxies are huge objects. The cell is a very, very small object, but you can see. You can see through the microscope all those things that your eye cannot see, right? Science gives you an ability to look at things much, much larger, much smaller, completely out of scale, and actually understand. Understand in a very precise sense, right? I mean, somewhere for the electric vehicles question, we must ask, okay, is it just all hype? There is an answer, there is a methodology, that's calculation. And you can do calculations, right? He will do let's leave it to Professor Banerjee to do the precise calculations and explain. But we can do back of the envelope calculations. And they call it back of the envelope calculation. Some very simple heuristics, simple estimates. We can actually get a pretty decent understanding of why what he says is correct. In fact, it is true that electric vehicles are much better in the long run, right? One must raise that question, but one must also do calculations, no? And this is really what science teaches us, right? You can look at data, right? And you have Srinivasan Ramani and Vignesh Radhakrishnan and people like that explaining data. If nothing else, you can at least hassle them to do a data point on electric vehicles, no? Right? So the point is that we can look for data, understand data. The moment we can start understanding these things, suddenly, our perception of all these things change. And that's what I want to say. So there are major systemic issues in these things, and these are things to be talked about. Kuruhama's identity as a Dalit girl. She's a first generation learner. There are no books, no gadgets at home. Her school has no library or laboratory, right? Maybe now that's happening, right? Schools do have libraries now. Government schools in Tamil Nadu do have. But, okay, so all this matters. The idioms of modern science are alien to Kuruhama. There are no planetaria, there is no science city, there is no internet that she has access to. The state supplied textbook is her sole link to formal science. Experiments are at best seen from a distance, at worst non-existent. But remember that what she knows is not acknowledged as science. Her extensive familiarity of the world around her, her hands-on experience with processes, ability to make things grow, to shape things, and to connect to nature, they are considered irrelevant. If our science communication takes the same attitude, you're going to have the same lack of communication. So school typically teaches her to see technology as given, not as constructed. But let's not be romantic. Let's not be romantic about her traditional knowledge either. She needs the language of modern science. I mean, she knows how to make things grow, but she doesn't know nitrogen fixation. She doesn't know about soil fertility. There's a lot that she needs to know, right? And the secrets that book hold. Experiential learning goes only so far. And remember, experiential learning comes with tremendous backwardness, superstition, and all kinds of backward forces pinning her down. We want Kuroma to be liberated. She needs even more the language of science that insists on quantification. This insistence on numbers, quantification, data is the fundamental learning that she needs, and science can give her that. So when she cannot speak the language of science, the entry to the world of science is denied her. And this is true for all science communication, right? We need to speak the language of the people so they can understand the language of science. If the language is alienating, that's it, right? As in other forms, in fact, language is a powerful means of social exclusion, perpetuating inequity. So I would say that we need to think about language very, very seriously. I write science in Tamil. I write science in Tamil for children, for general public. And I find that there, every word is loaded. I usually say not Tamil, but Tamilgal, right? There are like lots and lots of Tamils. And it's true when we speak, right? 5 sentences you speak in Indian languages, you are fixed completely, right? You are fixed by region, caste, community, in every way, right? So when you take science in this language, it's something that it accumulates its richness. Don't think of it only as problematic. Okay, let me not go down these things. So public understanding of science is not something to be taken for granted. Science education and science communication also should reflect the processes of science, right? And science has a critical role to play in democratic processes and in governance. And I would say this is a single line here. This is something that we talk about at length in our course, right? Because if science has no role in governance and in policy making, we are in for trouble, right? We can't talk about knowledge economy and have all kinds of great goals if science has very little say in these matters in an integral fashion. So we need public engagement with science to place science in the public agenda. Science is not on the public agenda in India, very, very far from it. As I said, it's definitely not in the political agenda. It is not part of political discourse. It's just something that stands as by a group of experts in some corner. As journalists, you cannot accept that, right? So March for Science, I wanted to mention this because this is going to happen on Sunday. This year's March for Science is happening in Sunday at 3 p.m. in Elliott's Beach. I hope people will come. Venkatesan is here, one of the coordinators for March for Science. I didn't even realize he was going to be here. So I'm delighted to see him here. Now, this has been happening for the last several years. This is simply as a public thing, as people taking out a procession, showing placards, saying, we march for science. This is something that came out of major concerns articulated by scientists across the world. Turning point was in 2016. There was this, 2016, Trump became president of the US. Early in 2017, the American Academy for Advancement of Science ran I see this nod. It's a beautiful.
He's a fellow.
You were there?
He's a fellow.
But I don't know if you were there in this conference. It was termed Doing Science in the Times of Trump. Now, to me, this is the US. You've got to take your hats off. A new president has taken over, and American Association for the Advancement of Science runs a conference called Doing Science in the Times of Trump. Fully subscribed, people sitting on aisles. There's a discussion, right? I wish, I don't want to tell you the title of the conference that I want to run, right? Okay. Please, maybe ACJ can host one. I will organize it if you let me. Okay. So, that conference flagged a whole lot of issues which led to March for Science. So 2017 was the first March for Science, but the inspiration really goes back to that conference, and I thought I should mention that. So the idea is to encourage public officials to make policies based on scientific facts and evidence. I've said it about 3-4 times, but I would underline that as one of the central goals of science journalism in the country. Opposing political attacks on the integrity of science. This is not to be taken for granted at all in India. Encouraging the public to support science. and seeking funding for scientific research, of course, And I was amazed that after the very first March for Science, there was an article in the Hindu, there was an article where somebody said, oh, this is all about, these guys want more funding, and of course they want. It's true, we want more funding, but there is a whole lot of other reasons as well. And promoting science education and scientific literacy among the public. Okay, so if nothing else, all you have got to spend is one afternoon, but it's an afternoon on Elliott's Beach, for God's sake. Come, right? It may be raining, but I hope it won't, but just come and march for science.
Bessie Beach. Bessie Beach. You should call it Bessie.
Oh, Bessie. Okay, sorry. I'm really gray hairs, yeah. So, science as an important weapon, I think I've mentioned this. Let me not go on to this. I think I cannot end this without mentioning this aggressiveness of the nationalistic sentiment in recent times. A systematic attempt at rejection of Western science to discover Indian roots in science. Now, so, I mean, this is one question that I usually ask, and I've asked many audiences. When was calculus discovered in India? And then the options are 2000 years before Newton, 200 years before Newton, with the arrival of the Europeans. I found that in general, I take a vote, largely either it's 2000 years before science or with the arrival of the Europeans, right? Now, I put calculus within quotes here. The truth is that it's somewhere around 200 years before Newton. And this was the Kerala School of Mathematics, Madhava and Srikanta and Nilakanta and people like that. I mean, they did beautiful summations of infinite series. The Gregory series, Lorentz series were all discovered by people in India. I can give you a very nice history of mathematics of that kind. That's not the point. The point is why it bothers me that educated audiences either vote for 2000 years before or with the arrival of Europeans. That's because we don't have a historical consciousness about these things at all. What is 2000 years before Newton? You can always say 5000 years before, 2000 years before. You have no clue what any of that period means to you. That's really what it means, right? The point should be, our discussion should not be about traditional versus modern. It should be about scientific versus unscientific. The traditional can be scientific, the modern can be unscientific. All possibilities, there are 4 possibilities and all 4 exist. Confusing the need for a non-Eurocentric history of science with a glorification of an imagined past. Now, this seems to be a prevalent disease, and if you are doing science communication, you cannot ignore this. The culture of public debate needs to be informed by the scientific temper. So, one of the most urgent needs, I would say, is climate change, conservation of our environment. But there is a whole new breed of romantic environmentalism that is not rooted in science. I mean, in our science journalism course, we have had extensive discussions. Many students naturally come with this thing, any mega project is wrong. Large science is wrong. It comes out of a justified indignation. But let's be clear about it, it's a very romantic notion. Unfortunately, this is not true. You need to do calculations. Sorry, I've come from math science, right? So you need to calculate, you need to look at data. Nothing is simple. Professor Banerjee said you should do real analysis. I would add complex analysis as well. Resist simplicity. I mean, Rajinikanth cannot come and solve our problems. Problems are complex. Our society is complex. That very simple answers which say reject this, oppose this, welcome this. No, binaries don't work at all. Non-binary is needed even in this context, right? So complexity is something that we need to look at. And if you're going to be a journalist, whether it's science journalist or sports journalist or whatever, it doesn't matter. If you are going to look for completely simplistic answers, binary answers, you're going to do more harm than good. So I would say complexity is very important. Understanding complexity is important. And unfortunately, most of these simplistic answers lead to anti-science attitudes. So understanding the needs of development and environment together means grappling with complexity, resisting quick, easy and unscientific conclusions. And I would say this is a very serious danger confronting us. I mean, I grew up in a time when environmentalism or environment education didn't exist. And I remember in early 90s, I was part of the slogan shouting crowd saying environmentalism should be taught in school, environment studies. Now it's taught in school. But it has reduced environmentalism to planting trees, and do plant trees. Huh? Yes. But it's not that, right? The damage that we are talking about. This romantic environmentalism is doing great danger, right? So complexity is very important. So last words, right? So once again, science and public decision making have remained alienated from each other in our society. And the gravest issues before humanity are perhaps poverty alleviation, climate change, and public health. And this is about humanity. Half the world lives in China, India, and Indonesia, right? Let's not forget that, right? So the challenges that we are talking about for humanity, we need to ensure that our society commits to science and seeks solutions to its problems in a scientific manner. And I would say the urgent thing is a democratically rooted confidence in our SNT, right? It's not just this thing. We need to be confident that science and technology can solve problems. And I am very much part of that crowd. I want to shout slogans saying science and technology can solve problems, right? It teaches you a critical attitude, and that is the right way to think about problem solving. Only when critique, experiment, and dialogue are central in the public arena can science act as a tool for social transformation. And I think science can act as a tool for social transformation that is much, much needed in a country that is deeply riven by all kinds of divisions like ours. And of course, this cannot happen without transforming the science classroom, our classrooms. Thank you. Sorry, I have a postscript. Yeah, I think that is already.
Yeah, there's one here.
Yeah, I think it's okay.
My name is Obrodeep. So some of the problems you spoke about, like confronting science classrooms particularly, I mean, I come from a background in history. So what I felt for a long time was that history classrooms in school also face a lot of the same problems, which is what leads people to become alienated from studying history and actually taking it forward. So when I think about how science education began for most of us, it starts with the history of science within classrooms itself. So my question is, when you talk about experiential learning and critical thinking from a very young age, don't you think the history of science, when you teach that itself, don't you think instead of, I'm not saying that Newton or Plato or Aryabhatta, all these people aren't important and you shouldn't teach them, but don't you think it should start from not from there, but from a different place? Something that talks more about understanding the past and understanding how to think about the past in a critical way.
Yeah.
Something like that.
So this is why I referred to historical consciousness, right? So, and this is really a problem, and to look at engage with history critically as well. That's absolutely essential. And history of concepts is very important, whether you teach mathematics or science or whatever. And a social history is also important. We don't do any of that. So certainly, classroom transformation is fundamental to whatever I'm saying. But I would say that it's not only for classrooms, it's not only for sites of education, but sites of communication. I would say in what you write as well. No, so this is one of the reasons history of science is also a component in the science journalism class, in more and more commercials, but it's integral to that. It's very difficult to think about understanding of science without history of science. And there are excellent readings, good books on these things. Yeah. And the history of materialistic explanations. It's extremely important.
Sir, I wanted to ask about higher education in science. So we can see that to get into higher education, it is laden with a lot of standardized tests. So how can we, and most people don't do well in such tests, like you need to be good at memory and stuff like that to be good at it. So how can we test the potential of children into entering science education without such tests?
Okay. So I think there are two problems here. One is mass examinations, right? Board examinations are needed for a certain purpose, right? Because in this country, I can't say leave it to the school to, because it's a caste-ridden society. It's a deeply division. So I need something objective where the state certifies that you have passed, right? So board examinations, mass examinations are important, and mass examinations, when you're talking about lakhs and lakhs, are problematic. But the shadow of the board exam looms so long, right? Looms so large that it affects your class 7 September examination, right? And this is ridiculous, right? So this because it's all high stakes. And of course, that's another problem altogether. But this is at school level, at university level as well, university exams and what happens in the classroom and assessments. And the idea that science can be assessed without any experimentation, right? Or what is called experimentation. In science lab, those reports, the lab records they are called, right? How do lab records look? They look beautiful. They look colorful. In Tamil we say Muttu Mutta Manimaniya, you know. You go and look at the log book of any scientist, it will have sambar on it, it will have all kinds of things on it, it will be dirty, torn, but it will be real data. We privilege our record books are things that are beautifully produced but all lies, right? So I think this is the problem, right? How can you test science if you're not testing experimentation? So, and process assessment is something that we are pathetic at. Nalini, I hope you are good at it, right? So we reduce everything to product assessment, right? So we're pretty nasty, terrible when it comes to processes. So I would like mathematics assessment to be about assessment of visualization, abstraction skills, generalization, representation. That's the heart of mathematics. But so this is, you know, so then it becomes a ritual, it becomes a memorization. Yeah.
We can take one more question.
Hi, sir. So till 12th grade, I did biomaths, and after that, I joined economics. So as a science student, I always used to challenge why there was no element of science in economics. So in my third year, we did a subject called environmental economics, and we assessed. Then there are subjects called risks and benefit analysis. And you were saying, so when companies come out with big projects, when we challenge the environmental aspect of it, it's a rather romantic aspect, you know, this thing, that's what you're saying. So can you elaborate on the link between science, numbers, and environment?
Okay. Again, you have a whole course on this, I think, right? You have a full semester course on this, and it's got to be engaged with in that kind of depth. It's extremely important, mainly because, I mean, I don't know how you can learn either economics or about the environment without understanding data, right? So data analysis is fundamental to this whole business, right? And if you don't, then you're not, you know, doing justice to either of the fields. So of course science is essential to it. I would say mathematics, some mathematical thinking is essential to it. Understanding of data is extreme. You know, statistical inference lies at the heart of many of these things. I hope you asked the converse question as well. Why is there no economics in science education or society, right? I got very good degrees in engineering, like I said. I never did a course called Science and Society. Why is it not a compulsory course, right? How can I become a certified technologist without having even one semester course on Science and Society compulsorily? No. So we are we have all these compartmentalized ways of looking at knowledge and engaging with that. Suddenly, somehow, when you come to public engagement, policy, understanding society, understanding politics, we are supposed to apply all these things, right? It's a problem. You guys are going to change it all, not me. So, but these are the things that we want to think about and raise demands for. Please understand. I'm saying, since I'm talking to journalists, these are all not things that we talk about in our chai table conversation and forget about it. In the public, you want to raise these demands. We want to change the shape of all these things, right? And it can happen. We need a loud enough voice for all these things.
Sir, I'd just like to add on to Nivedita's question. So when science, you talked about science education, but given that the education of science itself is not accessible to most people in the society today, how can we go ahead and talk about science for whom and science by whom? And a more straightforward question to you would be, how many people do you see in the field today from different backgrounds of the society, and if it is homogenized, then is there scope for development?
Thanks. Thank you for asking this question. I didn't plan this. Okay. Because I said that as my first lesson in science communication. And I also said I have been doing this nonsense for 30 years. Right? So it's not just been that. Right? The point is you can talk a lot of science. I ended about that account of that evening by saying we were talking about nebulae and supernovae and so on. Right? So the point is that once you get past this language of science, the alienating language that we have got, right? Once you talk to people in their language, there is a lot of communication possible, right? A lot of heuristics are possible. The term heuristics is that you are not talking about something that is valid, that has universal validity, but it's got restricted domains of validity. But within that you can communicate a lot. You can bring it down to very simple problems, points, posers. You can do a lot. But that's, not easy, but it's something you can do, right? You can do at various levels, and however complex the first question that you had was, my answer is positive in that. My answer is hopeful. It is possible to do, except that we are doing it on a very, very small scale now. Science communication in this country is pathetically small, literally, abysmally small. And that is restricted to largely English language among urban elites. When it comes to the large rural population, forget rural, small town population, the reach of English for science communication is very, very, very difficult. It's really Indian languages, and there it's pathetically, abysmally small. But the point is that whatever little does communicate, whatever little does seem to do much better than it should, really, right? So I would say, I would end on that hopeful note, right? It's just that the point is that it's not even taken very seriously among the policy makers, right? To produce a breed of science communicators, ensure that they've got jobs, ensure they can make a living, right? This is all not trivial. So we are very far from all that, and in the public discourse, science-based policy, discussions of science in whether it's electric vehicles or metro rail or any of these things, discussing it in scientific terms, when it comes to public health, we are very far from that. But I think wherever there are attempts, in general they have been positive. And I think people are enormously receptive. I've even taught adult education classes. We have done some science for neoliterates, we have got publications we have taken, and where we do, it gets great response. But these are, very, very small efforts for the scale of this country.
Thank you very much, Dr. Ramanujam.